Hi, welcome to Learning Monkey. I am Raghuveer. In this class, we will discuss about symmetric binary tree or not. The explanation is completely based on the assumption you already have some basic coding knowledge. If you are not good at basic coding, please visit our website learningmonkey.in, take the course Placement Training for Service-Based Companies, then come to the competitive coding. Coming to today's example, given a binary tree, our task is to check the binary tree is symmetrical or not. Other way, you can call it as mirror image of itself or not. You have to make this example in a time complexity of order of n and a space complexity of order of h. H means height of the binary tree. So how to do that? Let's take an example. First we will understand what symmetric means. If you take this binary tree 1, 2, 2. See, if you place a mirror in between this, in the mirror this half exactly looks like the second half. That is what symmetric means. 2, 2, 3, it shows 3 here. 4, 4, 5, 5, 6, 6. If your binary tree satisfies this mirror image for each and every node, then we can say it as it's a symmetric binary tree. Similarly, if you take here 1, 2, 2, what's the left side? None. What's the right side here? None. Yes, it is a symmetric. If you see 4 here, for here the left side will be 4. So by looking at the image, you can identify the logic. So what's the logic we need to apply here? Let's try to understand step by step what's the logic we need to understand. So before going into the logic, we are going to refresh the concepts of recursion concept. One function calling other function, one function calling f of function calling the f of again calling. The last function is returning true. It is returning true. It is returning true. This is what it is going to be if you use return function, return value in the functions. If any one of the function returned false, the entire output is going to be commit as false. So we are going to use this concept here. That's why we want to refresh this concept. Why we need this concept? Let's try to understand. See, you need to check two values. See, you take two variables. One variable is pointing to this node, another variable is pointing to this node. So the value present here and here should be same. Then you have to check for the left side node, left node, right side node, right node. So the next checking should be this node left side and this node right side. This node right side and this node left side should be same. That is what we need to check. So our function needs two variables, root 1 and root 2. One pointing here, one another pointing here. Each time this function is calling two separate functions. Each time the function is calling two separate functions. One function is going to call this node left side and this node right side. Another function is going to call this node right side and this node left side. See, when you start here, one node pointing here and another node pointing here. One variable pointing here and another node pointing here. If both are none, it is accepted. See, that is the case here. The left side, if the node pointing here, the variable that pointing to this node, if it calls the left hand side and right hand side of this node, both are none, you can accept it as a true value. So our conditions is like this. If both nodes are pointing, both nodes means here root 1 and root 2 are none, you can return true. What's the next condition you have to check? If both are not none, both the nodes are not none, you have to check for the equality of the value. If both nodes are not null, not none means you have to check these values are same or not. If they are same, Next you have to call left side and right side. Next you have to call return f of one function and another function. What's this function is going to call? This node's left side and this node's right side. Addresses are sent as an input to this function, and this node's right side and this node left side is sent as an address to this function, input passing as parameters to this function. We are placing and here. Understand it. Why we are placing and here? This condition, whatever the condition we discussed here, that condition should be accepted by each and every node. Accepted by each and every node. Whenever you call this function, it is going to check the condition for these two nodes. Next time it is going to check condition for these two nodes. Next time it is going to check the condition for these two nodes. So all the functions should return true. Otherwise the entire output is false. Any one node missing that condition, entire output should be false. In order to do that, so that's why f of and f of true, then only the entire output will be true. If any one thing return false, the entire output will be false. So this is how we write the logic for checking the symmetric of a binary tree or not. Hope this example will help you in many of the other situations. So this is the base logic you need to understand. This logic will help you in many of the other situations also. So we are showing the code here. So our suggestion is to write the code on your own, then check for anyhow the coding is available in our website learningmonkey.in. You can copy the code and you can use the code. See here, if root 1 is none and root 2 is none, both are none, returning true. If root 1 is not none and root 2 is not none, we have to check for the data is equal or not. Then return root 1.left and root 2.right. This is one function, and root 1.right and root 2.left. This is another function. If these two conditions are not satisfied, you have to return false. Hope you understand this example. If you have any questions regarding the concept, please post your questions in the comment section below. Thanks for watching. If you haven't subscribed to our channel, please subscribe to our channel and press bell icon for the latest updates. Thank you.